guys, this is Unit 6, Lesson 11, Analyzing a Data Set. We're going to do a quick little review. Linear functions have data points that follow a straight path. This straight line can have a positive slope, increasing from left to right. This one is a positive slope. A negative slope, decreasing from left to right. Or a zero slope, which is a horizontal line. That is a constant from left to right. It doesn't slope up or down. A linear function consistently follows a straight path with no curves to the shape. It has to be a straight line. Linear functions have a constant rate of change or slope, and the first difference of a linear function will always be the same number for each pair of adjacent y values. If you don't remember what the first difference is, we'll go over it, don't worry. Linear functions are always written in the formula y equals mx plus b. If you don't know that, naturally off the top of your head, you want that formula in your notes. Okay. A quadratic function can have points that create a U-shape curved called a parabola, and the parabola can open up or down. Okay. Quadratic functions take two steps to determine if the data in a table represents a quadratic function. First, you find the difference between consecutive values of y, which is the first difference we were just talking about, and then you find the differences of the first differences. That's called the second difference, and if the second differences are constant, then the data in the table represents a quadratic function. Again, if you don't remember this or it's not too familiar, don't worry, we're going to go over it. Quadratic functions are written with the formula f of x is equal to ax squared plus bx plus c. If you need this stuff in your notes, put it in your notes. Here's exponential functions. They show either growth or decay. The growth starts out with a flat, nearly horizontal line and quickly increases to create a sharp curve that quickly grows in a vertical direction. This shows growth. Decay starts high on the graph and steeply declines to a nearly flat or almost horizontal line. So it just goes the opposite direction. It's the mirror image of this. Tables of exponential functions have a common ratio in their y values. So the table increases by a multiplication value, not addition. Okay? And they're written in the formula f of x is equal to a times b raised to the power of x. Okay? Here's example number 1. Imagine you are growing a plant in your science class and collecting the data of the growth every day for a week of school, Monday through Friday. Does the plant growth data display linear, quadratic, or exponential growth? So we have our table of information, and we're going to figure out which type of formula we have, okay? So the easiest way, obviously, to do this would be to just plug it into GeoGebra, but I'm going to show you how to do it with the table because that's the information that they want you to get. We will be using GeoGebra later, but you can look at the table and use the table to determine which type of function you have. So if we look here, this is just going up by 1, 1, 2, 3, 4, 5, our x values are. If we look at our y values, they're increasing at a constant rate, 0, 2, 4, 6, 8. Okay? Every day yields another 2 centimeters of growth for your plant. As the x values increase by 1 each day, the y values increase by a constant rate of 2. So this is talking about our first differences. So we've done this before. If you don't remember, let me change. Okay, our first differences just mean we're going to take 2 minus 0, okay, which is this next lowest number on the table, is equal to 2. So there's a difference of 2. If we do 4 minus 2, which is the next lowest number, the difference is 2. If we do 6 minus 4, which is the next adjacent number, we get 2. And if we do 8 minus 6, which is the next adjacent y value, we get 2. All of these numbers are the same. This is the first difference. When your first differences are all the same number, then you're going to have a linear function, okay? And you're done. It's just that easy. When the first difference is the same, all the numbers are the same, it's a linear function, okay? And then if you graphed these points on GeoGebra, this is what it would look like, and you can tell looking at this, it's a linear function. It's a straight line, okay? Here's example number 2. Imagine you have a small orchard, and each new section of trees you add makes your daily workload grow. Let X be the number of orchard sections you expand into, and Y be the total hours of work needed each day. Even if X equals 0, no sections, you have no orchards, you will still spend 1 hour on basic tasks, such as checking the property and keeping records. After that, each extra orchard section adds a lot more work because tasks such as pruning, watering, and pest control become more complicated as you keep expanding. Examining the XY chart and determine what type of function is represented before considering the shape of its line on a graph. Okay, so again, we're going to use the table to try to figure out what kind of function we're dealing with. So if we look at this table, we're going to find our first differences. That's the first step in every time we're using the table. So our x values just go up by 1, okay? But our first differences, let's figure this out. So we're going to go 2 minus 1 is equal to 1. 5 minus 2 is equal to 3. So already we know it's not linear because these two answers are not the same. 10 minus 5, will give us 5. 17 minus 10 will give us 7. 26 minus 17 will give us 9. And 37 minus 26 will give us 11. Okay? So what do you notice about these first differences? Well, they're not all the same number, so it's not a linear function. But they do have a pattern. They're going 1, 3, 5, 7, 9, 11. Okay? They're increasing at a steady rate. Okay? So there's no common difference in the initial set of values. It's not all the same number. Since the first differences are not the same, the function is not linear. So let's find the second differences. So we have 3 minus 1. We're just doing the same thing over again. Gives us 2. 5 minus 3 gives us 2. Oh, we're seeing something exciting. 7 minus 5 is 2. Oh, this is a good thing. 9 minus 7 equals 2, and 11 minus 9 equals 2. So what do we notice about our second differences here? They're all the same number. That's a good thing. If the second differences of a function yields a constant value, then that function is quadratic. So we now know what type of function we have. We have a quadratic function. If we enter all of this information, our x and y values, into GeoGebra, this is what our graph looks like. Okay? The table feature of GeoGebra creates the graph of the function as shown. These data points create the right-hand side of a U-shaped curve, parabola. If you use the regression feature of GeoGebra, you would notice that the left-hand side of the curve would continue to create the parabola. So this continues. It's easy to look at this and think maybe it's exponential, but remember, exponentials are almost flat and then go up. You can see this is going back up, okay? The initial graph shows only part of the parabola because it comes from a small data set. We only have a few data points here, and none of them are negative. So that's why it's only showing us half of the parabolic curve, okay? It's not exponential, it's coming back up. It didn't level out over here like it would with an exponential graph, okay? Here's example number 3. Zane is studying the growth of bacteria in a petri dish for his college biology class. At the beginning of his lab, he counts the number of bacteria and records it in his lab notes. He does the same thing at the top of every hour for the next 6 hours. He then summarizes his data in the chart. What type of function best models the growth of bacteria for Zane's biology lab? So each y value seems to be twice the size of the y value immediately before it. We can just look at this and see it's got a pattern: 10, 20, 40, 80, 160, 320, 640. If we start to find the first differences here, 20 minus 10 is 10, 40 minus 20 is 20. Okay, so we have 10 here, we have 20 here, 80 minus 40 is 40. You can see the pattern. They're doubling each time. That means multiplication. And multiplication means a ratio. Ratio means exponential. So this means the y values increase by a common ratio of 2 for each increase of 1 in the x value. A table that shows y values increasing by a common factor, that's another term that indicates multiplication, indicates that the data are modeling an exponential function. So when it's increasing by a multiplication, by a factor, by a ratio, it has to be exponential. If you take these x and y values and plug them into GeoGebra, you can see it's level, and then it increases very quickly. Okay? That level thing is important. This one is scooping back up and will continue to make a parabola. This one is just going to continue to be level. There is no going back up. Here is question 1. This is your turn. Which type of function does the XY chart represent? Pause it, figure it out, come back. So the first thing we need to do is look at it and try to figure out the common difference, the first differences, okay? So 7 minus 12 is going to give us a negative 5, okay? 10 minus 7 is going to give us 3. 21 minus 10 is going to give us 11. 40 minus 21 is going to give us 19. 67 minus 40 is going to give us, I can do this, 47. I'm probably getting these wrong. I'm not good at math. 102 minus 67, I am totally getting my calculator for that because I doubt myself. Let's see. 102 minus 67 equals 35. Okay, well, obviously, we don't have a linear because these are not all the same number. So let's continue on and see if we can find a second difference and make it a nice, pretty pattern. Okay, so we have 3 minus a negative 5, so that would be 3 plus 5 would give us 8. Okay, 11 minus 3 would also give us 8. 19 minus 11 would give us 8. I probably did this wrong. 47 minus 19. Let's see. 47 minus 19. That says 28. I probably did it wrong because, you know, I'm me. And 67 minus 35. 67 minus 35 gives us 32. Okay. So now what we're looking at is we have 888, which would indicate a parabola, and then 28 and 32, which would indicate factoring, right? A ratio. So let's come over here and see what they say. This is a quadratic function because the second differences are constant. So I probably did the math wrong here or typed something wrong here. This is quadratic because it's constant, so it would be a parabola or a parabola, okay? Here's question number 2. Which type of function does the XY chart represent? Pause it, figure it out, come back. I bet you can do better than me. All right, let's look at this. We're going up by ones here, and then we've got 2/3, 1, 3/2, 9/4, 27/8, and 81/16. Now, I don't do fractions. I will tell you that right now. So this one would be extremely hard for me. So if I do the first differences, 1 minus 2/3 is going to give us 1/3. Okay. 3/2 minus 1. Oh my goodness. I don't even know if my lame little calculator does fractions. Let's go clear all. 3/2 minus 1 would give us 0.5. So that's 1/2 here. Okay. So obviously this isn't linear. Okay. So let's see what this, I guess we need to do another one. 9/4. This is difficult for me. 9 divided by 4 gives us 2.25. And we're going to subtract 0.5 from that. So that would give us 1 3/4, but they're doing improper fractions. So we'd have 4, which would be 4 7/4, I believe. Okay. So this pattern it's not linear. We know that much. Okay. Let's see. 1/2 minus 1/3. Oh, geez. I hate math. Okay. 1/2 is 0.5 minus 1/3 is 0.33. That gives us 0.17. We're just going to go with this to see if these match. Let's go 7/4. Yeah, come back, calculator. You probably have a better calculator than I do because you're smarter than me. So 7 divided by 4 gives us 1.75 minus 0.5 gives us 1.25. Okay, so it's not, the second differences don't work. So you know what that tells me? There's only one option left, and that has to be exponential, which means we're multiplying. Okay, now it only wants to know what type of what type of function it is, so I don't have to figure out what the ratio is. So I'm just going to go exponential and move on. This is an exponential growth function because the ratios of consecutive values of y are constant and the ratio is greater than 1. Now this nonsense they never taught us, and so it doesn't matter. We eliminated the other two, so it has to be exponential. Good for us, right? Okay, this is practice question 1 at the end of your lesson. Which data set represents a quadratic function? Pause it, figure it out, come back. Okay, a quadratic function means that the first differences are all the same. So 16 minus 4 is 12. 64 minus 16 is a lot more than 12, so it's not this one. 32 minus 25 is calculator time, don't care. 32 minus 25 is 7. Okay. And 41 minus 32 is like 9, I think. Let me double check. 41 minus 32. Yeah, is 9, so it's not this one. They're not matching. Okay, 0.25 minus 0.5. Again, I don't trust myself. 0.25 minus 0.5 is negative 0.25. Negative 0.25. I'm trying to write little. Okay. Now let's get the next one. We have 0.125 minus 0.25 gives us negative 0.125, so it's not that one. So it has to be this one, but we're going to double check. Negative 26 plus 23, because it's at minus, subtracting a negative. I can do this. I can. This would be a negative 3. Negative 29 plus 26 would be a negative 3. Ooh, ooh, ooh. Negative 32 plus 29 would be a negative 3. This is our winner chicken dinner. Okay. Here's number 2. Which type of function best models the data in the table? Pause it, figure it out, come back. Okay, let's look at it. We're going 3, 9, 27, 81, 23. We're increasing really rapidly. That tells me, it's not going to be a first difference. It's not going to, 9 minus 3 is 6. 27 minus 9 is a lot more than 6. So linear is out. Cubic is not a real thing. Okay, so I'm guessing it's going to be exponential. 9 divided by 3 is 3. 27 divided by 9 is a 3. 81 divided by 27, calculator. 81 divided by 27 is, oh my gosh, guys, it's 3. Let's go 243 just to be safe. 243 divided by 81 is 3. So guess what, guys? It's exponential. I care about this so much. Here's quick check question 1. I will not give you the answer, but I will tell you how to find it. Which of the following best models the data in the table? Well, one of these doesn't exist. Okay, so find your first difference. If that's not it, find your second difference. If that's not it, then it's exponential. I believe in you. Here's quick check question number 2. Which type of function best models the data in the table? Well, one of these doesn't exist. Okay, find your first difference. If that doesn't work, find your second difference. If that doesn't work, then it's exponential. Woohoo! Okay, example number 1. Determine the equation of the function that best models the data in the table. Use the table function on GeoGebra. So what you're going to do is, we've done this before. You should have all the steps written down in your notebook. You're going to go to GeoGebra and you're going to use the table function and you're going to enter all this into your table and it's going to graph it for you and you're going to get something like this. Okay? The data points appear to follow a line. So we're going to use the regression feature to find the equation of the linear function that best fits the data set. Okay, I will do this with you when we get to the actual questions as a refresher, so don't stress. Okay, and it will give you the equation of y equals 11.5x minus 10. This means that the hourly rate of pay is $11.50. Okay, $10 is subtracted from the take-home pay regardless of the number of hours worked, so it might correspond to the daily cost of gas and or parking. Okay, here's example number 2. You're studying the relationship between the distance a boat has traveled in a river and its speed. The x values represent the distance traveled in kilometers, with negative values indicating upstream travel away from the dock and positive values indicating downstream travel from the dock. The y values represent the speed of the boat in kilometers per hour. Use GeoGebra to determine the equation of the function that best models the data in the table. I'll go ahead and show you this example. For some reason, GeoGebra and the book are not vibing with each other, and I'm not sure why. Let's try this one again. Imagine you're given a data set about the number of new cases of sickness a large office workplace is experiencing over the course of 1 week, Monday through Friday. In this instance, you'll use Monday as day 1 and number the days continuously until Friday, day 5. And we're going to use GeoGebra to determine the equation of the function that best models the data. So first we'll go table. Our x values are 1, 2, 3, 4, and 5. Oops, not 55. We'll come over here to our next column, and we've got 2, 4, 8, 16, and 32. Okay, it's going to automatically plot this for us, and if you look, you can see we've got a curve to this line. So this is going to be an exponential blah, blah, blah formula. Okay, so we're going to come here. We're going to use regression. We're going to change this to exponential. Okay, and look, it's doing it again. Okay, be sure, oh, it wants growth, not exponential. That's my problem. Okay, we're going to plot it. Then we're going to come here. Woo-hoo-hoo-hoo-hoo-hoo. We're going to show our value, and there's our formula. Okay, that's why you got to make sure and click growth, not exponential. Growth is the key here. Okay, so our formula is y is equal to 2 raised to the power of x, which is totally what we should have. Okay, so now it wants us to estimate the number of workers that are going to be sick on day 6. So to do that, we're going to grab our little tools, and we're going to go y is equal to 2 raised to the power of 6 for day 6. Okay, grab my calculator. We're going to go 2, there's 1, 2, 3, 4, 5, 6. There should be 64 people sick on day 6. Okay, so it should be somewhere up in there. Oh, look at that, it's on the line. Okay, let's talk about coefficient of determination. This is actually really helpful for stupid people like me. What if you just don't know what kind of function it is? You just can't figure it out. Well, you need to use the coefficient of determination. So each time the regression window is opened in GeoGebra, it displays a value of r squared near the bottom of the window. This is called the coefficient of determination. If the regression equation is a perfect fit, r squared will equal 1. So we want it to be 1, okay? If the regression equation is a very poor fit, it may not display a value of r squared at all. The closer the value of r squared is to 1, the better the regression equation models the data. Sometimes it's more difficult to determine the type of function that best models the data set from its graph. In those cases, it is best to find the regression equation for all 3 types of functions and note which function has the highest value of r squared. The function with the highest value of r squared is the best fit for the data set. So this last one that we did, especially on GeoGebra where it was kind of scrunched together, the curve was more like this, and it was hard to tell if it was a curve or if it was a straight line. In that case, you would do both functions in the regression, okay? You would do linear and growth, and then see which has the higher r squared value. You want it to be as close to or exactly on 1. And then you can be like, oh, okay, it's this one because it's got the r squared value of 1. Okay, this will help. Here's a check-in. A new video was posted online. You are tracking the number of times the video has been shared each day. Use GeoGebra to find the exponential function that best models the video shares over time, and then use your function to estimate the number of shares on day 7. So first, start with a clean slate. We're going to go table. Our x values are 1, 2, 3, 4, and 5. Come to the next column and do 10, 28, 82, 240, and 705. Zoom out so that we can see. So this one's kind of hard to tell because they're all so spread out, but I can tell by looking here that what we're going to be dealing with is exponential, and it also tells us that it's exponential here. Okay, the numbers grow way too quickly for it to be just linear. Okay, so what we're going to do is we're going to go here, we're going to go regression, we're going to put growth, not exponential. I learned my lesson. We're going to go plot, we're going to click on the line, and we're going to put show value, and there is our formula. Okay, now we're going to use this function to estimate the number of shares on day 7. So let's grab my marker, chink, and we're going to go y or f of x, they're interchangeable, is equal to, I'm only going to go to the hundredths place because I'm lazy, 3.38 times 2.9 raised to the power of 7. Okay, let's grab our calculator. So we have 2.9. There's 1, 2, 3, 4, 5, 6, 7. Okay, there's our first bit. That's a big number. Times 3.38 gives us that. There's our answer. On day 7, the video will have been shared about 5,830 times. Okay. Shink. Oh, they said 7,238. I probably did the math wrong. They've got 3.33. What did we get? 3.38. Okay, that would change it. 2.95. Okay, whatever, people. You know what? We know how to do it. Create an equation that best models the data set. Ha 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 ha. This is all you. Pause it, figure it out, come back. First thing we do is create a table, put in our x values, -3, -2, -1, 0, 1, 2, 3. Put in our y values, 19, 6, -1, oops, -2, 3, 14, 31. Zoom out and look at it. Oh my goodness. This is an interesting line. Okay, we're going to go regression. This is one that I can't tell you what it's going to be. So we're going to have to do all 3 types. So linear, look at this r squared value. 0.12. It's not linear. Let's try the next one. Let's go quadratic. Oh, look, r squared is equal to 1. We're done. That has to be it. Plot. Oh, I see. I was thinking the line went jing, 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 jing. I'm so dumb. Watch me go. Show value. And there's our formula. Okay. So the equation for this one is 3x squared plus 2x minus 2. Look at this. I did it right. Da, 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 da. Okay, here's question number 2. Create an equation that best models the data set. Go do it. I believe in you. All right, table. X values are -3, -2, -1, 0, 1, 2, 3, 8, 12. Let's do our Y values. 0.0625, 0.125, 0.25, 0.5, 124, 128, 2.048. Okay, let's look at this. Look at that. That's an exponential one. So we're going regression, and we're going growth. Ah, look at that. It doesn't have a good r squared value, though. Look at that. That has a terrible r squared value. So let's go back to linear. That has not very good. Let's go quadratic. Ew, they all have a terrible r squared value. Okay, so linear is 0.2, quadratic is 0.28, and growth, it's not growth. I guess it's quadratic then, because it's a little bit better than linear. I guess it would be quadratic. I guess it would be quadratic. Why did it do a straight line? That's linear. Let's go regression. We wanted quadratic. Okay. plot. This is being very interesting. Um, it's testing my abilities, which it shouldn't do because I'm not good at this stuff, man. That all looks correct. Let's go regression, growth. I would say this is growth, but it's not matching up with here, and I don't know why. I don't know what's going on. Let's get rid of this one. Let's get rid of this one. Let's get rid of this one. Wow. Okay. Regression. Growth. Plot. Okay, sure. Let's see what our equation is. And let's see what they say. They say we should have 0.5, which we have, times 2, which we don't really have. Hey, I can't read you. I can't read you. Oh, look, I have this outlier over here. And that's why, because I bet you they did a typo. I bet this is supposed to be 1.28. Let's try that. Okay. Let's go delete. Or maybe this is supposed to be, I bet this book screwed it up. I bet this is supposed to be 12.8, and I bet this is supposed to be 20.48. Okay, now let's try and see if this makes more sense. Growth. See, look at that R value. Look at how much better that is. Okay, let's go show value. Let's scooch this out of the way. So now we should have 0.5, which I can get, times, we still don't have 2, but raised to the power of x. I think they gave us the wrong information. And it's supposed to have a perfect value of 1. So yeah, they gave us the wrong information on this one. The point is, do you know how to do the steps? If you do, you're fine. Okay, here's practice question number 3. Which algebraic model best represents the data set on the Y chart? Let's clear it all. You go do this and then come back and we'll do it together. Oops. Our x value is 1, 2, 3, 4, 5. Our y values are 2, 5, 10, 17, 26. Let's look at this. I can see a curve, so we're going to go regression. I think it's growth. Okay, that's pretty close to 1. Let's go quadratic. Oh, it's quadratic. I was wrong. Plot. Let's grab this and let's get our value. So we should have f of x is equal to x squared plus 1, and it should say quadratic. So our correct answer here is option number 1. Here's practice question number 4. Which function best models the data set on the table? Go figure it out. Come back. Table, x values, -5, -2, -1, 0, 1, 2, 5, 8, 12. Chink. 6.2, 8.3, 9.1, 10, 11, 12.1, 16.1, 21.4, 31.4. Let's check it. Okay, that's got some curve to it, so I'm going to go regression. I'm guessing it's growth. That's pretty close. Let's check quadratic. Ooh, 9986, growth. Oh, okay, so it's going to be growth. Okay, so plot. Let's find our formula. So our formula is going to be f of x is 10.004 times 1.10, okay, raised to the power of x. It's going to be option number 2. Here is practice question number 5. Which exponential function best models the data in the table? Go do it, guys, and then come back. Don't be lazy. -2, -1, 0, 1, 2, 3, 1.75, 3.57, 14, 28, 56. That's looking exponential to me. Let's go regression, growth. Ah, look, we did it. It's right there. Plot. Let's grab this and show our value. So we have f of x is equal to 7 times 2 raised to the power of x. So it's option number 2 for me. Remember, they shuffle these options. Okay, quick check. Question 3. Create a quadratic model for the data set. In the XY chart, you're going to do the exact same steps we've been doing. Enter it, figure out which has the best r squared value. And there's your answer. Same for question number 4. And then it wants you to find the value for x is equal to -1. Okay, so you'll find your formula, and then you'll put -1 in there and find your answer. And then quick check question number 5. Same exact thing that we've been doing this whole time. And did you know tigers will totally eat you? Because they will.